Welcome. In this video we're going to start building a Robotron style game. The first thing we want to do, now that we have a player and enemy sprite, the player is shooting, eventually the enemy will shoot, but boxes are boring. So what we want to do is we want to be able to animate using sprite sheets. So I have two sprite sheets here. I have my pink unicorn and my dark unicorn, which will be my enemy. So I will use these two sprite sheets. Notice that in the sprite sheet we have 4 frames for going to the right, 4 frames going to the left, 4 frames where the sprite is effectively going to be moving up, and 4 frames where the sprite is moving down while it's facing forward. So that's how we are going to be able to cycle through those frames. So it's important we understand our sprite sheet. Now your sprite sheet could be as simple as a 2x4, a 3x4, it could be a 6x4. It depends on how finessed you want your walking animations to be with your sprite. But in my case, mine is just simply a 4x4 sheet. So what I'm going to do is go into my player here, and the first thing that we need to do is we're going to modify this so that we are working with integers instead of floats. When we start working with our sprite sheets and trying to get everything lined up, some of the methods that we work with only work with integers. So instead of having to worry about converting back and forth, we're just going to make that conversion right now. So the first thing I will do is change all of my floats to ints. And along the way of doing this, we are going to have to update a number of things in our code just to make sure that it all plays nice. We'll see that acceleration here where it's 0.4. That is not an integer, that is a float number because it's a decimal point, so we'll just change that to 1. We'll still see the acceleration happen, it just won't be as gradual, but that's going to be okay based on the chaos that's going to start happening within our game. Now we need to create a series of additional variables that we are going to be working with here. We need to store what is the current frame that we're animating. We need to know how many frames are in our animated sequence. So it is ideal if you build a sprite sheet that you, the easiest way to code it is if every animation, in this case I have 4 walking animations, but if we had jumping animations and crouching animations, and if they're all the same number of frames, that does simplify our code, but it's not the end of the world. So we do have some flexibility there as we work with it. So what I'm going to do is add some new variables here, and the new variables, these are going to all be for my sprite stuff. So I'll just put a little comment there reminding me of that. So the first one I will need is my current frame, and we need to know our current frame. We're going to need to know what is the offset. Are we offsetting an X or a Y value? In this case, our offset on X is going to be 0, but if we have a sprite sheet which combines multiple sprite images together, so it's technically a texture atlas, that's the industry term that we would use, then I would need to know what is my offset. So if I had my pink unicorn here and my dark unicorn sprites next to it, and it's just one image that I loaded, I would have a horizontal offset. So that would be an offset X. We'll have our offset Y, which we need that as we go through our different things as well. So we'll just put that in, because then if we have a more complex graphic, that's going to save us. So if we were to have a sprite sheet that looks like this, where we have multiple characters all on the same sprite sheet, we need to know what is our offset on X or what is our offset on Y for where we're grabbing our sprite data from. So that's how we could use those variables. So we're just going to code that in now, because as our game progresses, we may end up building a sheet like that, so we might as well pre-bake that into the code so we don't have to worry about it. But in our current sheet, our offset is going to just be 0 on that, so we don't have to worry too much about that. And now we need a couple more variables that we're going to work with. because remembering that we animate at somewhere between 30 to 60 frames a second, and we only have 4 frames for our animated loop, it's going to go really fast. We are going to have to kind of slow down our frame rate here, so we're going to have a hold and delay value that we work with. So those will come into play. So we'll code those in a little bit after we have got the sprite sheet showing up. So now let's give all of these values. So current frame will start out at 0. The good part is once we code all of this, a lot of the code that we're using here is going to be the same code we use on the enemy, so we'll be able to copy paste that, which will greatly speed up our production here. So our offset is going to, in this case, start out at 0, and then we're going to multiply it by the width because we're starting out, we're giving it a base value. Later on, we'll see where we need to modify that offset. So the width is based on then the size of our sprite. So then we repeat the same thing, offset y is times height. Our current row that we are going to start out with, we'll just set it to 0. And now we have these variables of sx and sy, and those are the shorthand that I'm using for source x. So that's keeping track of where's the x. So when I'm grabbing this frame, our source x and source y are 0, then it's going to be, in this case, my artwork is 32, not 50 wide. So we're going to have to modify our values up here as we work with it. So then it would be 32, and then 64, and then 86. So we can see how we just work our way across. So sx will start out at 0, sy starts out at 0, and because we're writing processing, anything that technically starts out at 0, well, we are able to not even define it in our thing, and it will default to 0. But that's a bad habit to get into, because in any other programming language, if you don't define a value for it, then you will get a null value error message. So we don't want to do that. Well, the delay through experience I know turns out to be 4. And that just happens to match our total number of frames for our sequence, which is 4. So our total frames could change. I mean, we could be changing that value based on which animated action we're trying to depict, but we'll just leave it at that for now. I'll just pull this down. Now, currently we're displaying a rectangle. Oh yeah, we need to change our value here. My artwork is 32 wide and 32 tall, so I'm going to put those in as my values. Now, when we're displaying the image, in the past we've used the image command, but if I use the image command, it shows the entire sprite sheet. But instead what we want to do is we want to copy pixels from this sprite sheet. So we use the copy command, and we now have to specify which image we want to copy. Well, we haven't put our image in yet, so we're going to reference the image object we're going to create here in a little bit, but this will be my player art. And then, so we're specifying where we're copying it from. So sx plus offset x, sy plus offset y, and then the width and the height area that we're copying. So because the sprite sheet is, the artwork is the same size we set for the height and width of our sprite, we just are specifying that. So we're specifying what is the rectangle area of pixels we're going to copy, and then we put in 4 more values, which is x, y, width. Oh, let me get a comma in there. Just looks better, or I mean a space in there. X, y, width, height. So now we are putting those in. Now we're getting an error message because we have not defined player art. It's like, well, that doesn't exist. Okay. All right, so let's wander over here, go into my main thing. So this is in my data folder. So we need to now create, in this case I need to create that. So p image, player art, and we'll also have enemy art. Might as well make that now as long as we're here. So with that, we'll just start putting that stuff down here, and we'll go player art equals load image. In this case, it's unicorn.png, and then we have enemy art equals load image unicorn dark.png. So that now loads those. If we go look back at the player, we're going to copy that. So our copying value will be, in this case, 0, 0 with that. And then the width and height, 32, 32. So it's going to copy those pixels. Then we'll display it at X, Y, width, and height. So let's see if we can get it to run without any, and it worked. It doesn't animate yet because, let's go over here so we can see, but it did work. So if we, right now I'm going to leave that box there, but I am going to just change my fill color to 80 and change that to yellow. Let's see how that looks. All right, that's a little better. So transparent yellow. All right, so now we have been able to load our artwork into that box and we're set up. But it's not animating yet. So this is where we want it to animate on screen. And the way that we are going to do that is we need to update our sprite art. So that's going to be inside the player class where we're updating, we're checking for the keys. So then we're changing our VX and VYs and all of that. We update our position, we check with our boundaries, and then the last part in update, this will be update sprite art. So the way that we can do that is we can just take our source X, and what we're going to do is we are going to multiply it by, or set it equal to the current frame times the width of the sprite. Now, what that also means is we need to update current frame. And we need to set our source Y for when we're working with a different one, because if we have our animations are set on rows, we just change which row. Current row is 0, and then we'll have row 1, row 2, and row 3. So we multiply the current row number by the height, and then that sets the source Y. So every time we change which direction we're animating, we are going to change row. When we change the row, it updates our source Y. Our source X updates based on the current frame. So if we run this, it's going to run. I am just going to take the enemy here, and while we're doing this, we're going to, I'm just going to eliminate the enemy temporarily so that it doesn't run over the player, so we can watch it happen right away. Alright, so here is our player. There's current frame, but current frame is not updating. So if we update our current frame, and we did look at using this method inside our updating our current projectile. So we're figuring out with projectiles where we're going based on a maximum number, the length of projectiles, and next projectile plus 1, or we can use the if statement. If, so projectile is equal to projectile plus 1. If next projectile is equal to projectile's length, then we reset it back to 0, so we create that loop. Well, we want to do that with frames, so it'd be current frame is equal to current frame plus 1 modulus total frames. So we will be able to do that, or you can use the if statement there. We'll just put both of those in so you can be entertained by it on it, so that we can update that. So if I go current frame is equal to, in parentheses, current frame plus 1 modulus total frames. So total frames was 4. So current frame starts out at 0. We add 1 to it. 1 divided by total frames 4. 1 divided by 4 is 0 with the remainder of 1. So now it's 1. And then current frame plus 1. So 1 plus 1 is 2. 2 divided by 4 is 0, remainder of 2. And then it will become 3. 3 divided by 4 is going to be 3 divided by 4 is 0, remainder of 3, and then 4 divided by 4 is 1, remainder of 0. So we just create this loop. So now if I run it, we'll see, and I'll just turn off this little box here even, so it's even easier to see, and run it, and we can see that our sprite is running really fast. Just going to scale it up for the purposes of the video. In our game, I think we are going to want to keep it kind of small because we're going to be planning on having a ton of enemies when it's all said and done. So we can see, yeah, he's animating, but he's going so ridiculously fast. And this is why we need to kind of slow him down. So we don't want to update our current frame every frame. We want to do it every few frames, or like in this case, my delay I'm setting to 4. So I want to do it every 4 frames. So we'll play with that delay to figure out what is the optimal number. So we'll do some attempts or some tests with it. Oh wait, I did promise the other method where we can go current frame is equal to current frame plus 1, and then if current frame is equal to total frames, and at that point we want to set current frame back to 0. So those 4 lines of code are equivalent to this 1 line of code. So we don't want to do it twice because that will actually break things down the road. But that is the other way of thinking about it. So if you like to do it this way and the modulus thing hurts your brain to think about, then use those 4 lines of code. I prefer doing this. So I'm just going to take those and get rid of them just because I'm going to need some space here. So what we can do is say, yeah, we can, every time hold is 0, we'll update our current frame. So we'll say if hold is equal to 0, we want to update our current frame, fix our indents with Command or Control T. So now if we run this again, it's still going to look the same because hold isn't being slowed down. So now let's slow down hold, and we do it the same way that I did with current frame. Hold is equal to parenthesis hold plus 1 modulus delay. And now our hold is 4, so now it's going every 4 frames, so now we can see it's working at a much better clip. And now I'm just going to get rid of that times 3. We don't need that anymore. And let's see. There we go. So now our sprite is animating. So we're using the hold to slow down. Now, based on your animation, maybe 4 isn't the right number, and for you, you'll get a better result if you go and choose something like 2. So we can see now in this case, I think that's a little too quick. With the speed too fast, we'll just go back to 4 and check that and see that that makes a better, based on my artwork, size of sprite, how it's moving on the frames, that's a better number. So your number will vary based on what you do. So total frames should, if it's animating, will be a minimum of 2, or the delay, total frames will be, if you have 2 frames, that would be the minimal for an animation. You need to set your delay though based on what you need. The more frames you have, the less you need to have that delay, but because I only have 4 frames, I really do need a delay. Now the next thing that we need to do is we need to modify which row that we are working with. So we can see that right is row 0, left is row 1, up is row 2, and down is row 3. So now if I go in the player and we look at, if I push left, not only do I want to set my speed, but I also want to change which row I am using. So if I'm going left, that would be row 1. So row equals 1. And it's really common when you're doing this that you grab the wrong number and you put it in the wrong place. Make sure that you are not putting that row inside the VX grid or the max speed up there, because once you hit your max speed, well, then it can't change or update the row or make sure it's the correct row. So make sure it's either right at the very beginning. And I'm just going to get rid of these hard-coded ones that I have in there just to clean up my code here a little bit, but also then it makes it easier to see so we don't have extra lines of comments in there. So it could just be, if we want, I'll just put it first. So if left, it's row 1. Otherwise, if it's right, row is equal to 0. And now if it's up, row is equal to 2. And if it's down, row is equal to 3. So which row you use will depend on how you set up your sprite. Make sure you are choosing the correct row. Now let's go test this so we can see where we're going. Now we go up, go down, go left, go right. So now we can go in all directions. Now if I think that 10 is too fast based on the size of my artwork, maybe I want to shorten this down and say 5 on it. So now I like that speed a little bit better. That seems to make a little bit more sense with it. And we can still, because this is left over from our shooting, we can see the shooting is, well, it's kind of shooting out his butt. But the shooting is now still working, so then that's good. So this is a good first step. We have that working for the player. Next, we're going to recycle most of this over onto the enemy. Adding things into the enemy, what I'll first do is I'll just copy these lines of the sprite stuff, go into the enemy, paste it in. We will notice we've got a couple things we have to update. Once again, we have to change our floats to ints. Now, one thing we'll see here is a random number. Random generates a floating value. It generates a value. I mean, if we kind of by default, it's going between 0 and 1, and now we're setting a range so we can, it's kind of a complex thing, but what we need to do is we need to round it down. We can see float does not match type with int. So what we typically do is we round down. So we use the floor method, so that says round down. We have floor to round down, ceiling to round up, and just plain round, which will round anything 0.5 and less down and greater than 0.5 up, or maybe 0.5 and up. I'm not sure exactly where 0.5 falls on that. I prefer to always round things down because we always want to end at 0, because when we are working, we're going to find that it, and now that the player, I think I modified the player's max speed to 5, we probably will want to slow that down a little bit. We'll just say 3 for the enemy. The enemy will accelerate 1 there. We need to update our size with it down to 32. We can leave the rest of it there. We can see that when it's updating its position with impact, we're probably going to change that because we'll just have enemies be hit, and we're going to institute a health bar so that as we strike the enemy, its health goes down. As the enemy attacks us, our health goes down. So we're going to have all kinds of fun happening within this game, but right now let's just work on getting the enemy sprite animating, and we will have to go back into our main code and reactivate that. So we can see I'm rounding down, gets rid of all of the red message is there. We set it to 32 because both sprite sheets are the same, just colored differently. So that now sets that up. We need to grab these so I can grab those values. And again, if my sprite sheets don't match, if they have more unique artwork, and we will be adding in a boss enemy and maybe other enemy types, so we'll have a couple things going on in this project as we build it out. And when we do that, it is going to, we will be changing things, so it's not going to be quite as cookie cutter here. But this gives us a decent starting point. And once again, we can just go down and grab updating our sprite artwork information. Oh, we might want to on the player here, I forgot, when the player is not moving. So when the player is stopped, so if it's not up and down, our Vy is 0. If it's not left and right, our Vx is 0. But we want one more use case in here where we will say if not up and not down and not left and not right, meaning we're not moving, at that point we want to stop animating. And we do that by saying current, gotta turn back off our cap locks, current frame is equal to 0. So now let's try that again. It's parked, so it animates. And it looks like it's working. I'm going to just scale it up here. Just multiply it by 4 because that's really small. I have tired eyes. All right, so it's not animating, animates, 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 and stops. Perfect. Okay, so when it's not animating, we set our current frame equal to 0, then that stops it. All right, so on the enemy, we need to go grab some display information, update information for our sprite art. So I'll update our sprite art there, copy that, go over here, paste that in, and then copy in, but we'll change which one we're looking at. Can just turn off the box for now, and we are going to be looking at enemy art. Now let's see. Oh, well, we won't see anything yet because the enemy is turned off because we said don't display the enemy. Now let's see the enemy again. There's the enemy, and the enemy is moving. It's animating, but you can see the enemy's row is not updating. So we do need to update the enemy's row. So we can look through and figure out, makes sense if we're moving left. So if we're moving left, row equals 1. If we're moving right, row equals 2, 0. If we're moving up, row equals 2. And if we're moving down, row equals 3. Now let's run this again, and we can see the enemy is chasing us down. Now let's go here, and the enemy chased. Good thing my speed is faster than the enemy. Okay, perfect. So the enemy changes based on what it's doing. When the enemy is not chasing right now, then what we can do is set it to stop moving. So right here, current frame equals 0. When it's not chasing, let's move out of the way, and now it parked its frame. Perfect. So we got an enemy it's chasing. We have some more work to do with it, but we're off to a good start.